Good morning, guys. So, what I'll be doing is I'll be solving problems. I'll just reinforce what we have learned. So, we'll be talking about still is in the chapter on electrochemistry. So, we'll be solving problems so that you won't say that um, I lack examples, of course. So that's my main motive. Why I put these videos online. Okay, so maybe we can try this one. Consider the electrolysis of molten barium chloride, BaCl2. You have A, B. Problems, you have one, write the half reactions, and then B, how many gram of barium metal can be produced by supplying 0.50 ampere for 30 minutes. So basically, for A, you just have write half reaction, write half reaction. So basically it would be talking about um, barium absorbing that electrons to be barium metal, because again for your electrolysis you are depositing a metal in the form of solid. When you have your barium is barium 2 plus. So our first problem is write the half reaction. Anyway, I think I might not be asking you to write reactions, but anyway, this is um important for us to understand really. So I may not ask you during quizzes, but again, I should do this as an example, of course. So you have barium and chloride. So basically, you can expect your barium, even only the barium, because barium is really the one being deposited. Because you have metal, your chloride is a non-metal. So basically, on elemental form, it will not form a metal because it's a non-metal. It's a gas, really. So the book is also expecting you that you should already be familiar with what are metals, which are the left side of your periodic table. So for barium chloride, actually, you can go back to your table of ions. Actually, you can write it in the soluble products as barium and then barium plus, barium 2 plus, sorry, barium 2 plus, and then you have your 2 moles of chloride ion. So actually, the book's already expecting that you know this one. Now, the second assumption that the book actually incorporates is you should know that this is the one who will be turning into a barium ion, the elemental form. Of course, for electrolysis, you are depositing a metal into a surface of a solid. So you're expecting that the book is expecting that you know how to write A, even if your teacher is not. No, of course, I will not be asking you this kind of problem, because I always go to problems which can be represented by ABCD, of course, for the sake of our quizzes and for the sake of long quizzes and exams. So you know for A that you'll be writing the half reaction of barium 2 plus, and then it will form a barium metal. So you did not be concerned with the chlorine. Of course, with the oxidation reduction reaction, we have to write probably chlorine, but it has to be written. Of course, the equation, the chemical equation is being supplied. But here, you're only just given a compound, and the book is expected you to really understand what is happening. Okay, so this is it. Your barium 2 plus will absorb 2 electrons, and it will form that barium metal. It's a solid form. So that's the first one for letter A. That's your half reaction for barium. Half reactions, maybe chlorine would be, but anyway, that's not really my concern, because during electrolysis, our only main concern is barium 2 plus. Okay? And the next, how many grams of barium metal can be produced by supplying 0.50 amperes for 30 minutes? So you now have a current electricity in the rate of, in the amount of 0.5 amperes. So this is actually the electricity that's being consumed. 0.5 amperes, of course, you have to put the how many minutes of course, for that to be already in terms of consumption of energy. So I think this you can already quantify how much energy is this one. So the question is, let's see, how many grams of barium metal? So it talks about how many grams of this, how many grams of this would be deposited if you will supply a zero point 0.5 amperes for 30 minutes. So let's say that is mass of barium metal. So that must come from this zero point 0.5 amperes for 30 minutes. So we will go back. What is an ampere in terms of coulomb per second? Oh, battery. Okay. So we know from our relationships that one column is 1 ampere per second. So meaning we just have to use this one to convert it to columns and then maybe use your Faraday's constant again. And then from Faraday's constant, maybe you can relate again the Avogadro's number, because your Avogadro's number will relate from mass to mole. So basically, you're asked about mass, and your Faraday's constant is in terms of mole and your current. Okay, so that's the you only have to connect what is needed. So I do believe you should start with zero point 0.5 amperes, and then probably you multiply this with the conversion factor. I think there are formulas for this, but I do believe plug chug method is fast for this one. So you convert one column is 1 amp per second, so meaning one column per second is 1 ampere. See, as you see from this relation, one column per second is 1 ampere. So we have already changed the ampere into column per second. So you have seconds there. Maybe you can attach the touch 30 minutes. 30 minutes. So and then convert. So 30 minutes multiplied because your second here is at the bottom. So 30 minutes and then have a conversion that is seconds at the top because the second is at the bottom here. So you have a 60 seconds for your 1 minute. So as you can see, your minute is cancelled and your seconds is also cancelled. So you're faced with column. Now we go to our Faraday's constant, that is 96,400 column per mole. 96,400 column per mole of electrons. From um, our equation, we have this is the mole of electrons. There are two. There are two. This is a stoichiometric ratio. 2 mole of electrons per 1 mole of barium. 1 mole of barium metal. So this is from your stoichiometry. Of course, the accounting of your elements or compounds. Barium. So we're talking about a solid now. We already have the mole of barium. Then maybe we can use our Avogadro's number, which is, do we have to? No. In this, we don't need the Avogadro's number because we will just compute for the mass. So we basically go to the formula weight. So formula weight, I think I have my formula weight here. No, formula weight here. So for barium, you have there you have 137,327. So we need that one. 137,327 grams per mole. 137.327 grams of barium per mole of barium. So by that, we can cancel the mole of barium, then mole of electron, mole of, where did I cancel this one? Okay. So all in all, you have all those numbers at the top. Zero point 0.5, then you have your 60, and then you have your 137.327, and then you have your 30 minutes. There's still the 30 units at the top would be grams of barium. That's the only thing left. And then at the bottom, you have 96,400, and then you have multiplied by 2. So that's the only, those are the only numbers. May I check with my calculator? Of course, 96,400. I think your Faraday's constant F is 22. May I see? Anyway, we can just plug it. Shift constant 22. Your F is 96,485. So 96,485. So may I correct this one? 96,485. 96,485 times 2. So there you go. I can just plug this point 0.5 times 60 times 137.327 times 30 all over 96,485 times 2. So all in all, we have 0.64 grams. 0.64 grams of, so that is so thin. 0.64 grams of a barium metal. So I guess that's the answer for that question. In significant figures, 0.640. So actually, we can still write that 0 here, 0.640. But for our answer with our multiple choice or with our all choice exams, our answers would be 6 and 4. That would be A, B, C, D, E, F. So that would be F, and A, B, C, D. So that would be an FD. Okay? So that's for your problem A and B. One problem lang para di rin matagal yung video. Thank you guys for listening.